Hey, welcome back, all. Hope you are having a fantastic weekend. And we are entered into the Q4. And let's continue our journey of the RAG generative AI with the structured data. In the last post, I had gone through the how the table augmented generation works in the same way the RAG retrieval augmented generation works. And there are an open source framework available for us to try it out and experience how we can implement the rags over the structured data. The framework or the Python library name is the Lotus. it its full name is language large language models over structured and unstructured data. So we will see it in action, how we can build the RAG using the Lotus and a structured data. So we will create one structured data, and then we will ask the questions in a natural language and get the results um, out of it. So this Lotus framework uses a concept called the semantic operators. Semantic operators is nothing but they combine the power of the relational model with the generative AI features. So I know it's a little bit confusing, but let's get see it in action, then get the more clarity on it. So I'm sharing my Google Colab so that we will go there and then try it out and see how we can create a tag. So this is my Google Colab notebook. I'm leveraging the Google Colab notebooks. Anyone can use it. So to play with this tag, you need to make an install the Python library, and the Python library is the Lotus AI. That's a large language models over table of unstructured and structured data. So I have installed for this demo already. So to run this program, we need the two things. One is like we need to have an OpenAI key, so that we will use an OpenAI while running the RAG, right? So in your tag, sorry, in your RAG, you need an OpenAI or like any LLM models, right? So the OpenAI is the most famous one. We are using it. So here in the first cell, what I'm trying to do is I'm trying to set my environment ready. So I imported this OpenAI model and the E5 model, and I set those I prepared my environment ready to run my tag. So I have created set the OpenAI key. So I have the OpenAI key, that my OpenAI key as part of the secrets on my notebook on my notebooks. I created a secret and then I gave a name as an open, and I am using that same name keys here to get the OpenAI key. You can also do it like when you are in the Google Colab, you can click on this one and then you can create your secrets like this. So that even if you share your notebook, nobody will see that. Okay, so we created we set up the environment ready. So and our Lotus environment is ready. So to see that what is the keys in it, like you can see that it has a dictionary of certain items like model params, language model, etc. Okay, so having said that one, so first we will do that one is first we will create structured data. So for this demo, we created a quick course data frame. So it has a course name, and it has all the course different related to the maths, arts, computers, and we are creating a data frame out of it. So this is a plain this process everybody knows. Most of the data engineers or software engineers or data scientists know this process. So the most interesting thing is that we are going to do a filter. The next action is filter. So how we are going to do is that we are going to find a course that requires a math. So if you look at this course name, some of the courses require the math, some of them not require the math. So if you see that one, art does not require the math, and design digital, I think it's also not required that. But let's try that one, because we are filtering the courses that requires the math, so that we so this we are sending this information the column to the LLM and asking it to filter out the courses which is not which is include the math. So the way to do that is that, so first we created a data frame, and we apply a semantic operation called the sem filter, and then we need to put the column name on which column we wanted to apply, and this is the column name we created it. That column you wanted to, a specific course requires a lot of math. So that's what we are trying to find it out. If we run this one, it is saying that probability and randomness is required some math. We know that optimization methods in engineering requires the math. Digital integrated design, integrated circuits requires the math. Computer security is not required the math, but it was saying that deep learning is requires the math. Computer networks not require the math, compilers not require the math. So arts and history is not required, right? So it was able to read the data, understand each column value and filter out that one. So this is different from the normal text to SQL, where you ask for a question in a natural language, it will generate a query for you. But here you are going one level down and looking at the each column value and then filtering out depends on the knowledge of the AI or the open AI. So the next operation is we wanted to find the top two records, top two rows from that our data frame. So we wanted to find the which course is most relevant to the distributed system, not the two, we have wanted to three. So some of the courses in this is related to the distributed system, like the deep learning is a distributed, and the optimization engineering is also distributed, right? So let me run this one. So yeah, here we saying that probability and randomness process requires a math, optimization methods in engineering requires a digital circuit requires the math, deep learning, graphics, art and history does not require the math, so it's not giving that information. So you are getting the results using the language expression. You are not writing any SQL query here, right? So that's a power of the Lotus. And the next one is the finding the finding the top K results. So computer networks is related to the computer distributed system, operating system, and system programming is and databases. So the same way, we can also join the two tables using the semantic operators. In typical relational model, we join by the exact column values, right? But here we can use semantic meaning to join the two tables. For this, for this one, first we created a data frame with the skill, and that skill is related to the course. So we created skill as an art, cryptography, and banking. And then we wanted to join taking which course will help me to good at a specific skill. So that's what we are writing here. So this is a course data frame, and this is a skill data frame that we created, and we are mentioning the taking the course, that the course name will make me better at the skill, one of the skill. So let's see how what it is going to do that one. So we are leveraging, we are combining the power of the relational model with the AI model, generative AI model. So if you take the probability and randomness process, you good at the cryptography. Computer security is related to the cryptography, and the graphics and art are related to the cryptography. And then we can do that in the traditional RAG systems. We use a vector database. Vector database is like converting your text into the numbers and storing into the vector stores. That is called the indexing, and then you can do the search on top of it, right? So we can do the same thing also. So we can index the as a specific column and then do the search on it. So here you don't need to store these indexes in any vector database. You can store it in memory. So the data frames is like in memory, right? So here I'm creating a semantic index on the course name, and I'm giving a name as a course name index directory, and then I'm doing a search on it. And when I'm doing the search, I'm giving the painting. So give me the courses that related to the painting, like the most related to match to the painting. So If you do this one, painting is related to the art history and the graphics, right? So that's why it's returning the for doing the semantic search on top of the course column and then giving the results. The same way we have seen the semantic join, right? So we can do the similarity join also. So the similarity join is what we are going to do is that one. We'll take the course, like we'll take the courses and we'll take the skill and then we will try to join the two data frames and then find the similarity between them. So the similarity is like, so the art and art history, skill is an art history is most like similar, right? Cryptography and then computer history has a similarity score of 89%. So this here we are going by the skill name. So for each skill we wanted only one record, that is we mentioned as a K1. So that's why we got the three records, because we have the three skills mentioned in our skills data frame. Okay, so if we give the true, then it will get the top two. For each one it will give the top two records. So we have, for we mentioned two, so that's why it's giving the two records for it for each skill. So the same way we can also cluster this data data by depends on the column name. So here we are doing a semantic clustering. It's not clustering by the value, it's a similarity meaning. So compilers, graphics, databases are related to the cluster one. Probability, randomness, distributed, integrates the computer security. These are related to the math as a one thing. So you can make the cluster by. So the map is like, if you wanted to give some transform your input to a certain output format, so that's you can do that. So here what we are taking, that we are asking to generate a short study plan to succeed in a course, this one. So that's how we are making the we are generating a plan for our course. So this giving the probability or randomness. So you need to take the to succeed in course, and so there is I think we need to expand this one. So yeah, let me see if I can see that. Yeah, I can see this one. For each course, I'm generating a study plan. It generated a specific study plan for me to learn good at that skill. So these are the some of the ways you can leverage your relational model capabilities and add any AI capabilities onto it, and then you can do the tag table augmented generations. So I'm going to share this notebook in the comment section so that you can try it on your own. Thank you for listening. Hope you enjoyed the recording session on the tag and Lotus library. Thank you.